All right. So today we're going to tackle some of the aspects that will have to do with you encountering when you get jobs. This course is called Network Cabling, but as you could probably notice by now, this is not just about running a cable from point A to point B. We are covering different aspects of pretty much installations and the reality of things. I'm trying to give you as much as possible the real world and the situations that you might encounter. Now, what I'm going to give you here is not going to make you complete 100% experts on these topics. However, it is going to give you a good starting point that you could expand your knowledge either by searching for more information, or if that would be the best thing, if you're going to get a job that is going to require you to deal with some of these aspects, then you're going to get a really good head start on this. All right. Okay, so today we're going to talk about some systems, three types of systems: security systems, fire alarms, and surveillance. Surveillance is basically, security cameras, right? So this whole thing well, for the most part, we are talking about data systems, wiring data, cables, Ethernet, internet, and networks and topology and whatnot. Uh, but then again, this is a very wide field, and you're going to well, you know what? You're going to see when you get there. Okay, so with a press, there we go. So for security alarm, here are a couple of one, two, three videos that I'm going to ask you to watch after this class. Right? And these are short, minute and a half kind of videos showing certain type of devices that you might encounter when you go on your when you follow your career with this type of business. And this is this whole thing spans over the area of um, infrastructure installations and systems as such. Right, so just click on those once you download this presentation. Now, here is what a typical main board looks like when it comes to security alarm. It will be a basic thing. Now, there are different types of systems, different brands, and whatnot. But for the most part, you're going to look for the same elements here. Now, can I zoom? Yes, I can zoom in. Good. All right. Now, there are a bunch of, electronic parts and processors that make the whole thing work. I'm going to point you to some common areas that you're going to be looking for. Well, here first you see that that kind of a watch type of a battery. This keeps all the memory that has to do with the date, hour, and some other things, just like a computer BIOS type of a memory. All right. If we move towards the left here, I'm not sure if you can see this or not, but here is a connector. And if you look carefully, you're going to see something that says red and black. This is the backup battery connector for the security alarm. If the power goes down, there is a backup battery that is going to keep the power for a certain amount of time. Now, when I was heavily into this kind of systems, the most common question would be by the clients would be, okay, so how long do we have? How long? Well, it depends, right? It depends how many motion sensors you have, how many glass break detectors you have. Those are the things. How many keypads you have? All those things that require power to operate, and then their power consumption. So it could be anywhere from an hour, 2 hours to maybe 6 hours, very rarely, all right? So that depends, all right? So there is no more definite answer, but at least there's something going on that if the power goes off for maybe like 10 minutes, 15 minutes, or an hour or something, you still have this whole system active, okay? And then again, there is no guarantees whatsoever. Installing a security alarm at a house or a business does not guarantee that somebody is not going to that nobody's going to break into your facility and steal something, right? Well, it's a deterrent, right? There's no guarantees because if somebody expects you to guarantee that, then you would say, yeah, I guarantee you that. Then what? They're going to take you to court. If somebody ignores that alarm system and breaks in anyways, you can't predict any of that. But it's a pretty well efficient deterrent that is going to make a big difference one way or the other. All right, now in some of those systems you're going to see something like in this particular one. It's the Digiplex Evo by Paradox. Over here you can see a serial port connector. In this here, you're going to plug in things like IP module that you could connect this whole board into the Ethernet network and work with the internet and communicate with the monitoring station if the client decides to purchase the monitoring of that. And there could be some other peripherals that require serial communication. Like, for example, if you want to use your laptop to program this system, your laptop serial interface will connect into this serial port, and then you would be able to communicate with this board and do the setup. And the setup would be setting up codes, setting up zones, setting up all kinds of things. Right. Then over here, it's not used as much. It says memory key. All the programming that is on the system can be stored on a something that's called a memory key. It used to be popular some years ago, before this programming with the laptop was very popular because you can save everything on your laptop. But I guess they still left it there. Right. We are not going to, very rarely you're going to use these connectors. That's for the external dialer and whatnot. That's, you know what, I've never used these in so many years that I have done. Service keypad, that is if you want to just get, if you do a lot of service on the systems and you have a keypad in your van that you just don't want to do some keypad programming that you have to go to somebody's bedroom or basement or something, wherever the keypad is, then you can just plug in that keypad right here. Now, let's take a look at some of the peripherals here. I'm going to analyze this thing from left to right. AC. This is where you plug in the power. And, well, for the most part, the doorbell transformer is going to work. It's about 18 volts AC, and there are transformers sold that could be wired in or plug-in transformers. A plug-in transformer is basically kind of like a half a brick looking like thing that has the prongs for the hydro, for the receptacle. You plug it in, and it has screw terminals that you can connect the two conductors, and they go and they connect right there into that. I'm pointing at my screen here, right here. Yeah. The wire-in transformer is also, it looks like the doorbell transformer. It wires in, it fits a knockout in the electrical panel, so you can mount this thing right onto the electrical panel and wire that into the electrical panel and have a designated circuit breaker for that. And on the other side, there are a couple of screw terminals that you could use to power up this AC. So between here and here, you would have something like 18 volts AC. Right? This one here says bell, plus and minus. It is for the siren. A bell is a siren. Right? So there used to be in the old days. Used to be that mechanical bells. So I guess that terminology has transferred into today's times. So that is basically a siren. That is going to produce 12 volts DC, and the siren looks like a paging horn for the most part, and sometimes they're just square boxes that mount on the wall or in the ceiling or something like that. And once that thing receives 12 volts DC, then it is going to go, well, what some people would call crazy. And the tone that it produces and the volume that it introduces that tone with, it is supposed to work on human ears and brain that you just don't want to be in there. Right? All right, program 1, 2, 3, and 4. This one has 4 program buttons, program terminals. Now, I'm not going to get into too much details because different systems will have different ways of solving the program thing. The program could be those program things in some cases could be programmed so that between the common terminal and whatever that thing, you could have a voltage, or you could have a dry contact relay on that. You will have to look at the system's manual or contact the support or attend one of the training sessions that whatever the company sells that would do, and they do have training sessions. Here is the common. Common is a common. It's just like a ground or common terminal. And here is the relay, dry contact. So it's just a relay, normally open and normally closed. So it's like a double pole, single throw switch. That when this, and it can be programmed that it is idling at normally open, which means there would be no connection between these 2 points. And there will be a connection here between these 2 points because normally closed. And when this thing gets activated, this thing reverses. There's a connection between these 2 points and there's no connection between these 2 points. Now, if these program terminals are designed in a way that when one of the program terminals is activated, then there is a 12 volt DC voltage on it. Then in combination with the dry relay contact, you could control all kinds of other, maybe some of them third-party devices, like door strikes, some other things that need to be powered up or need a dry contact relay. So you have a bit of a flexibility, and how exactly this thing works varies from brand to brand, from manufacturer to manufacturer. Here is the next strip here. It one says AUX, all right, auxiliary. That stands for auxiliary. This is across these terminals there is power. 12 volt DC constantly, it's there. These 2 terminals are powering up active devices. An active device is a device that needs power to operate. Like, for example, a motion sensor has electronics in it. It needs to be powered to operate. A glass break detector has electronics in it and also needs power to be operated, and so on. There could be some other keypad needs power. So all those are being connected in parallel right up to here. Keypads, motion sensors, glass break detectors, well, whatever else. There could be even some expansion boards could be getting power. Now, mind you, you should consult the manual of this system to see what the ampacity of that is, how much load it can handle, what's the maximum current draw that it can handle, and you can only add so many motion sensors and so many keypads and so many other smart devices before this thing says, okay, you know what, that's as much as I can handle. So, I'm not going to work if you keep loading me like that, right? So if there are more devices that you can connect, then you can get power expansion boards and you can install that beside this thing here, and it gets its own separate power and separate backup battery and whatnot. Now here, remember we're talking about the network topologies. This is the bus terminal, and it has only 2 wires. That gets connected to any bus terminal of any smart devices. Usually it would be a keypad. So this system is capable of handling many keypads at once. You could have one keypad in your lobby, you could have another keypad in your bedroom, you could have another keypad in your basement, you could have another keypad in some other doorway, whatever. So you could have many keypads, and those communicate with this main board through a bus topology. So there's just one pair of wires going, and it's terminated at the bus terminal of one device, and in a parallel way also keeps going, tapping in a bus configuration. Now you see this one shows green and yellow. That's because the cables that are being used for the alarm systems, they're typically called Z type of cables. Well, for the most part, it's a quad, which would have 4 conductors, and it's using the old color code for pots, which would be yellow, red, and black, green, red, black, and yellow. Right? But when it comes to terminating the alarm systems, the color code is tiny bit different. For the most part, we're going to use black and red for the power, and we're going to use yellow and green for any kind of signal that's coming out of the device. So if it's a door contact, it just has a contact closure or opening. You would only connect the yellow and green. You would not even connect the black and red to the door contact because it's just a magnetic switch. You bring the magnet to the switch closes, and you take the magnet away from the switch opens. So there is no power required for that. So you would use yellow and green when it comes to connecting the signals. But when you could use the same cable to connect smart devices such as keypads, that you would use that cable. So you would connect red and black to the power, and you would connect yellow and green to as a signal bus. All right. So that's as far as this auxiliary power / the communications bus terminals. Okay. Now here's another area in this, and you can see those Z. These are the zones: zone 1, zone 2, zone 3, zone 4, 5, 6, 7, and 8. This board, as it is capable of handling 8 zones. What is a zone? A zone is a contact point. If the zone is active, for the most part, it can be programmed as normally open or normally closed, sorry. So if the system sees a connection, if you just run a wire between here and here, you're going to close the zone, and the system is going to be at ease. If it's not armed, it is not going to indicate on the keypad that this zone is open. If it is armed and it is programmed for alarm if the zone opens, so if you just disconnect the wire that will connect from here to here, the system would go into some sort of a trigger state. And if it's programmed that the zone 1, if it opens, go into alarm, or it could be programmed have a 30-second delay and then go into alarm. And 30-second delay would be if you enter your house, you have 30 seconds to enter the code before the whole thing just goes nuts. All right. Or it could be programmed as a 24-hour loop. So it doesn't matter if it's if the system is armed or disarmed. if that zone opens, or if something happens to that zone that is described as a trigger action, then doesn't matter if this alarm is armed or not, it will go into alarm state. A good example of that would be a, well, sunk pump water detector, the water level detector. You could also be connecting some smoke detectors. You could also be connecting some heat detectors. So it's sort of might act as part of the fire prevention, right? So then, obviously, you don't need to have this thing armed for this thing to let you know that there's a fire in the basement or something like that. Right? So these are fully programmable, right? And they can trigger on a different basis. The most common one is just a closed loop, idle. Loop opens, there is a condition. If it's armed, act certain way. If it's disarmed, just let me know that that door is open. Now, the zones can group different type of connectors. Like, for example, on zone 1, you can connect all the living room windows. So you don't need to put every window in different zone. You can just group them. Right? On zone 2, you can put all the garage doors. On zone 3, for example, you could put other devices like living room motion detectors or first floor motion detectors. You get the idea, right? So that means you can have way more contact points than the zones. And 8 zones is a pretty much good optimal solution for small business / residential thing. Now, this can be expandable in more than one way. You could have an expansion board with another 8 zones. So we have 16 zones. You can wire these into doubling zones. So you could use something like the called end-of-line resistor. If you are interested in this kind of stuff, there's an opportunity to run your own business when you have things like when you know how to do these. Talk to me. I'll put you in the right direction. I spent many years installing those, so I know a thing or two about these things, right? Now, you can see also those common points. These are all connected to each other. This one is connected to that, and it's the same point. It's the same point where there's a common here. There's another one here. These are all internally connected as if they were just short wire, shorting this thing. So when you're doing a lot of wiring, let's say, for example, this common point is close to zone 1, 2, and 3, so maybe you're going to run those wires close to this one, and then for convenience, this is closer if you want to continue, but these are the same points. Here is the dialer. Now, the system can communicate with something that's called a monitoring station. The alarms do not communicate directly with police or fire department. Alarms communicate with something that are called monitoring stations. And then again, if you're interested in this type of business, if you want to do this thing yourself, if you're thinking about that, talk to me. I will set you at the right direction, and I'll tell you what the monitoring stations are, where they are, how to contact them in order to make business out of it. Yeah. This here, you see that T1? Okay, look, tip and ring, and tip 1 and ring 1. You would use this terminal, under his ground. This terminal would be used if you want this system to communicate with the monitoring station through the POTS line. It's becoming less and less because what's becoming more popular is this thing right here, that you can connect something that's called an IP module, and it is a very small thing that just clips on right above onto the box. And on one side you have a cable that connects into the serial port, and on the other side you have an Ethernet jack that you can just connect right to the network. But still we have availability to one of the ways is also to connect through the phone line, POTS line. How is this thing wired? You can see tip and ring, remember, yellow-green? Or the first two pairs, the two middle prongs of the jack, that's tip and ring. And here's tip one. Does it mean you can connect two telephone lines? No. It means that if properly installed, this alarm system gets to have the phone line first. So if there is a phone line coming from the outside, it is wired straight into the alarm system first. And then out of that, the connection is carried on, and then the rest of the house gets the phone line. It has to go through this. The reason for that is that if there is a burglary situation happening, or if there's an alarm condition, if someone is talking on the phone in the house, this takes the priority. It will cut that person off, hang up the line, and then pick it up again, dial the number, communicate with the monitoring station, and then after that it's done, it's going to hang up the line, release the line to the rest of the house. So that's why we have the tip and ring. Okay, you just learned something. All right, and of course here is the fuse, and this fuse goes together with in this particular system, this fuse goes together with the backup battery here. If you plug this, the terminals will be plus 12 and, well, neutral type of black and red. So here's a 0, here's plus 12 volts DC. And this thing, it will be constantly charging the battery. And if, well, the battery is needed, then the battery is going to provide the power for it. So it's also a battery charger. If for some reason there is an overload, here's the fuse. Or if you, by accident, if you plug this in reverse, if you plug in red where the black is supposed to be and black where the red is supposed to be, you're going to create a huge amount of current. Poof, this fuse goes. Is there, I think this one says 3 amps here. All right, let's move to the next thing here. We just, you know what, these would be the zoomed. Okay, let me just go through here. Here, that's where the battery goes. See that? Okay. Now, how is it that the contacts are wired to the zones? Here's a typical example of a door contact. The door contacts, for the most part, are employing things that are called reed switches. It's nothing to do with reading or reading glasses. It's something to do with the reed, R-E-E-D, which is the reed in maybe like a saxophone piece that vibrates. Reed. It looks like a reed. That's why it's called reed, because it looks like a reed. It's normally open. When you bring the magnet close to it, that thing closes. So here is the reed switch inside the door contact, and over here is the magnet. This would be mounted on the door frame. This would be mounted on the door itself. There you go. You have a door contact. There is no window contacts, all right? All those parts employ something that's called a door contact, and sometimes they are called, how many DCs, nothing to do with the DC power. The DC stands for door contact. So if you want to arm the window, you would use a door contact, all right? Okay, so that's what it is. And you see, over here, we're using that yellow and green. And for the most part, the green will be connected to the common terminal of the zone, and the yellow will be connected to the signal. However, because it is just a free hanging kind of a not attached dry connection, if you reverse those, it's not going to make a difference. However, just to make things nice and consistent, for the most part, you're going to see this type of stuff. Now, if you have more than one, like if, let's say you want to put 3 windows that are beside each other in the living room, and you want to put them on the same zone, and then say west wall living room windows or something like that, You can put them in series. You can run those wires between those windows, so you can bring the wire here to the first contact, and you can run a wire from one window to another, from one window to another, close the loop, and you're going to have a series loop. And it is supposed to be, the loop supposed to be closed. So if all the windows are closed, then the whole loop is closed. If one of them opens, the whole thing is just open, and it could trigger a condition, like an alarm condition. These are called passive devices because they do not need to be powered. So that's why we only use the signal wires for that. So if there is a zone terminal at the alarm panel, the red and black wires would just not be connected to anything. Now there's another one. So here's the normally closed or normally open window sensor or door contact. Here is single normally closed sensor with an end-of-line resistor. Here's another way you can program the system. You can program the system not to look for a closed loop. You can program the system to look for a certain type of resistance. And that varies slightly between systems and manufacturers. So when you have a closed loop, this thing is going to see the value of the resistor, and then it's going to say, okay, I'm at ease. If you open the loop, then it goes into the condition. If you close the loop, it also is going to go to trigger a condition. Now, some of the systems will let you combine these. You can put this and that on the same zone, and you can tell that system that this is what you have done in the programming, and it is going to treat this as zone 1 and treat the other one as zone 2. So that's how you can double the zones. I try to avoid that kind of situation altogether. However, it is possible. So you can have 16 zone panel out of an 8 zone board if the system is capable of doing that. All right, how is it? How are we doing it? How is it that the motion sensors work? Well, the motion sensor is an active device. It needs to be powered. This would be the inside. Oops. Yeah. This would be the inside right here of the motion sensor. You see 1, 2, 3, 4, but look at that. 1, 2, 3, 4, 5, 6. Let's just take a look at the 4 terminals, and I'll tell you what the other 2 are. Well, power. It needs to get power. Where is this thing connected? To the auxiliary. Remember the auxiliary terminal at the security panel? So that's where this thing goes. And here is the signal. Just like the door contact, the security panel zone is looking for either open or closed. That's all it's interested. All the rest that is happening here is how that thing is triggered, and this thing is based on motion. So this particular one works on infrared. It looks for infrared signature of a person, or well, usually a person, and if it sees a movement of that, then it is going to trigger into a condition. That's why these motion sensors should not be pointing at a door that maybe there's a draft there, or a window that is too much cold in the winter and too much warm coming through the window in the summer. They should not also be installed in front of fireplaces, wood stoves, heaters, and whatnot. A heater can trigger the alarm on that thing. And they should also not be pointing at each other because it's an infrared. Some of them employ microwave technology, and some of them laser beams and whatnot. So what are the other 2? These are tamper terminals. When you put the cover on, it closes a thumper switch or tamper switch, not tamper, tamper switch or tamper switch. If somebody is tampering with that, then they're going to have to open that, take the cover off, and that is going to release that switch, and that is also going to trigger the alarm. It could be wired in series with the sensor terminals. So here is the alarm zone. Here's a zone, security alarm contact point, right? And these would be the sensors in series because you need to have a closed loop. So that's how security alarm works. Wires. There's a Z type of cable. See, you see red, green, black, and yellow, and you would use black and red for power, and you would use the yellow and green for the signal. One thing I'm going to point out to you, remember I'm so rigorous and strict about you keeping the twist on the data installations. And the Z cable has no twist. We should not install twisted pairs onto the sensors. The reason for that is that if the conductor of the pair is long enough and if it's twisted, a twist has certain inductive capabilities, inductive properties. And what do inductors hate? Inductor is a coil. Because it's a twist, it has certain characteristics of a coil. Coils do not like change. The more drastic the change happens, more drastically the change happens, the more it opposes. So it needs a little time of delay to settle down. So here's what happens. If you have a longer cable, and if you sometimes open and close the door very fast, if the cable is long enough, has enough inductance, that inductor that is made out of that pair might prevent the signal from coming through. So that's why we should have untwisted pairs for that. Sensors associated with the alarm systems, with motion sensors, dark contacts, glass break detectors, smoke detectors, heat detectors, water level detectors, seismic detectors. These are detectors, sensors that sense vibrations, quite often being mounted on safes in the banks and whatnot. Panic buttons. My mouse keeps disappearing. Panic buttons. Well, that's in retail or banking or whatnot. You could have a panic button, which basically, if there's some kind of a dangerous situation, you press that button. And if that facility is a high security facility, if somebody presses that button, even by mistake, you're going to have all kinds of things triggered, and you have, well, if you're lucky, you're just going to have a little paperwork to fill out. All right. And those sensors could be wired or could be wireless. Wireless technology has improved over the years to the point that is equally as good as wired, almost equally as good. There's nothing better than wired. Wire is a wire, right? You don't need to have a battery. You don't have to deal with any kind of possibility of interference or blinding the wireless signal. But sometimes you just have to use wireless contacts. Now, wireless contacts or wireless sensors are more expensive than the wired and way more expensive. Like, for example, it might cost just a couple bucks, $5 or something for a dark contact. And some of the wireless dark contacts could be about $100. However, it takes less time to install a wireless contact because you don't have to run the wire. So for the client's point of view, when it comes to the clients paying the money for that, it doesn't matter whether it's wireless or wired, because yes, the wireless contact costs more, but you spend less time, so it kind of balances out. Annunciators for the alarms, so bell, siren, strobe light, and there could be silent alarms. So the alarm could be hidden. Somebody walks in, Well, there's no alarm. Well, there is one. It's just silent. All of a sudden, there's a bunch of things happening, right? Control. What do we control these with? We control it with keypads. We control it with laptops or PCs, right? In order to program that, right? And you can access them through IP, Internet Protocol, so IP modules, which means you can plug in your laptop instead of to the alarm system, you can plug in your laptop to the network and call up the alarm system and do the programming, or you can access that remotely from a different location and still programming. And wireless remote control. The remote all these could be associated with the programming and setting things up. This one here could be just a remote control for user. Yes, the alarm systems can have a remote control. It's quite useful device because you can have that alarm system programmed in something that's called a stay mode. Just like you're staying somewhere, it's called a stay mode. Some of the sensors, like the outside parameter sensors, like would be the door contacts, the window contacts, and everything that separates the inside from the outside, there could be armed for the night. However, all the inside sensors, like inside motion sensors and whatnot, they could be programmed so when the system is alarmed in a stay mode, then they are not active. It's just whatever protects you from the outside. So if you just want to go wake up in the middle of the night and go to the fridge, have a drink of water, you're not going to trigger the alarm, and it's also, but it's whilst the alarm is still armed. Okay, but if somebody tries to get in from the outside, yeah. So you could use the wireless remote control if you don't have a keypad in your bedroom. Well, just arm it with a remote control. The other thing is that remote control, it's pretty much a sales thing. It made those devices sell quite well, and it makes sense. If you're coming home and you sense that something is not right, you just get that airy feeling. Yeah? Well, you have your remote control with you. You make sure you arm the alarm. Make sure the alarm is armed. If somebody is in there, they're going to move. They're going to trigger the alarm. Interfacing access control systems. So what can we interface the alarm system with? Security alarm system. We can interface it with something that's called access control. And access control could be a standalone modules that control the access to the building, door strikes and whatnot. So the sensors, the door contacts that are servicing the alarm system can be also working together with the access control. Access control is swipe the card to get in, inside doors or from outside. They could be programmed in various ways. Like, for example, real estate agencies employ that feature a lot because they have a lot of agents, and well, they come and go. So let's say there's a company that employs 80 people, 80 agents, and there's a small company, small building. So yes, sometimes you're going to have somebody leave the company and some new people coming into the company. It's always happening. So what are you going to do? You're going to cut the mechanical keys for everybody. And if somebody leaves, then, well, you're going to have to replace the lock and cut the keys for everybody else. No, you just give them the access cards. If somebody leaves, you just deprogram their card. Okay, so access control is very popular thing. It's just one of the examples. The the fire alarm system can be the security alarm can be interfaced with the fire alarm. They can work together. One can trigger the other, or the other can trigger. They can trigger each other. It can be interfaced with monitors. Well, sorry, monitoring. It could be programmed to access a monitoring station. The monitoring station is a business that does what it says it does. It does monitoring. It has many accounts, and if there is certain alarm that's being triggered, it communicates with the monitoring station, and there's always a human that watches that. It's not just, press 1 for this, but usually monitoring stations, you dial them, there's a human that's gonna. If there's no human answers that, you get the menu, maybe you should consider other monitoring station. And I'm not swaying one way or the other, and I'm not associated with any of those right now. Okay, so that could be, and here's my favorite, others, right? I always leave that. Okay, we have done the security alarms, and okay, you know what, just before we move on to the fire alarm, we're going to continue with that next time we see each other. Devices, passive devices with door contacts, window contacts, right? Overhead garage contacts, anything that involves magnet. There could be surface mount, flash mount, sump pump sensors. And so there's not magnet, it's just like a lever. Just closes, okay, closes contact, open the close contact. They do not require power. Excuse me. Active devices will be keypads, expansion boards, motion sensors, glass break detectors, water sensors, and here's my favorite, others. Here are some references that if you want to click and see some of those devices, go ahead, all right? Now, before I let you go, I'm just going to, what was going to mention? Glass break detectors. I explained to you how more or less how the motion sensors work. They could be infrared technology or microwave technology or laser beams. Glass break detectors. It's pretty interesting animal how this one works. If you have a cat that is in your home, it will be like an indoor cat because it's inside. And if the cat walks on the countertop, knocks off the like a glass of milk that was on the countertop that you left, is that supposed to trigger the alarm? No, because that would be considered a false alarm. So how does this one work? It is supposed to, it has a microphone and it has something else there. Microphone detects the sound. What happens if somebody throws a brick through a window or breaks the window? There are three things that are going to happen. One is going to be that high pitch of the beginning of the glass breaking, and like that shudder high pitch sound. It is also going to be associated with the low frequency rumble of the whole membrane moving, the glass moving. It's there. You might not hear it, but it's there. But that microphone is going to hear it. And also, it's going to be associated with the sudden pressure change in the room. Those three things are present, the glass break detector is going to trigger. For the most part, there could be some cheap ones, not all of them, because there could be hundreds of different manufacturers that maybe skip one or two of those, and there would be, those. If those three are not present and the thing still happens, then you could have a false alarm. False alarms are not welcomed by the monitoring stations because it's a waste of time for them. They could be servicing another client that really need help. Police definitely don't like to be sent to the false alarm situations, to the point that you get so many a year, and depends on the municipality. In different cities, they have different bylaws that some of them will let you have one or two false alarms per year, and then you really have to do something about it, and then you have to pay money for them to respond. Some of them, every time there's a false alarm, they just send you a bill. So false alarms are not that welcome. All right. Okay. So and there are water sensors and others. Okay. So I just explained to you how glass break detectors. All right. I think that's enough for us to intake at one session. Next time we're going to take a look at some fire alarms and some security surveillance systems. All right. What's today? Thursday. Almost Friday. And how now I know that? You know how I know that. Because every day is almost Friday. Thank you very much, and I will see you when I see you next time. Thank you, guys.